Exercise question set number 9. All right, so first question for this one. Yeah. If you're not familiar with the formulas we have learned, then it could be pretty hard, right? Yeah. Because it's very hard to verify each formula. Yeah. Not that easy, although you can try. Yeah. All right, but here you need to use the knowledge of that Fibonacci numbers. Do you know the formula of the Fibonacci numbers? That formula. So this one. If you know it, we know Fibonacci number f of n equals this one, and it must be integer, right? Positive integer, yeah. Integer, yeah. Then you can get the answer this one easily. The other two, yeah. Replace phi by pi, the first one. Second, replace phi by e, yeah. So you can see it is unlikely to get an integer, yeah, because the Fibonacci number closely related to the golden ratio, right? Golden ratio, yeah. So this format is for the golden ratio format. Now you replace the golden ratio by pi, but the format is not right, right? You know, yeah. And by e, the format is not right. Okay, yeah. And especially golden ratio, another intrinsic property here is the golden ratio phi is a root of the quadratic equation for the Fibonacci numbers. That is the characteristic equation. Characteristic equation. Yeah. All right. But here, pi or e, they can never be a root of any algebraic equations. Okay, yeah. So that's another concept, another fact we know. So yeah, this is also a famous fact. So they cannot be a root of any algebraic equation. Okay, yeah. All right, so that is our first question. This one is a little hard. Yeah. Phi golden ratio. Then how to represent 1 over phi squared minus 2 phi in the form of a phi plus b, where a and b are two integers. Now, this one you need to do transformation, formula transformation. But to do the formula transformation, you need to have the key properties for the golden ratio. Yeah. We are given a fractional form about golden ratio, phi, 1 over phi squared minus 2 phi. Yeah. Our goal, we need to represent it in a linear form. So this one, a phi plus b. So this is a linear form. Okay, linear form is more friendly than a fractional form in general. Yeah. So we want to, do that kind of transformation, formula transformation. But in order to do that, we need to use the properties for the golden ratio. Remember, we have two properties. One phi squared equals phi plus 1. Another equal, just a different way to write this one, minus phi, right? Yeah, these two. Yeah. So here we need to use these properties in a very smart way. Yeah. So try to, explore the right way to use these two properties. All right, so let me show you the work here. 1 over phi squared minus 2 phi. Okay. First, you can imagine because we may replace phi squared by phi plus 1. Yeah, so that's easy to see. 1 over phi plus 1 minus 2 phi. After simplification, 1 minus phi. All right. Next, that is the critical step. How to do next? That is the critical step. All right. One way we can do, so 1, can we replace that 1 by phi squared minus phi? Can we replace that? Yes. Yep. Why not? Right? Now we can try it. Yeah. All right. So when we replace it, phi squared minus phi over 1 minus phi, bam! Can we factor common factor of the numerator phi out? Then we have phi minus 1 over 1 minus phi. Then let's examine phi minus 1 and 1 minus phi. Just the opposite, right? We can do cancellation and get a negative sign after cancellation. So we will get a negative phi. That's the A plus B linear form, right? A phi plus B linear form. Here, A equals negative 1 and B equals to 0. Yeah. So we solve the problem in this way. Yeah. All right, so that's the second example. Yeah. The third and then the last example, solve quadratic. Yeah, no, not quadratic. Yeah. So remember the long name for this kind of recurrence relation, right? Yeah. Second order linear homogeneous recurrence relation. All right, so let's solve it. Yeah. To solve this question, so let me write the standard steps. Okay, yeah, standard steps. Okay, yeah. Because each question in our homework or midterm tests, final test, 4 points. Each question, 4 points each, right? Yeah. Here, assume this is one of the questions in homework or tests. Yeah. So I tell you, how do I grade question like this? Yeah. Here we have 4 steps. Each step 1 point. All right. So step 1, the standard steps to solve second order linear homogeneous recurrence relation. The first step, we write the characteristic equation. Here it is a quadratic equation. Okay, yeah. All right. X squared equals 4x minus 2 here. The lowest term corresponds to the constant. Next term corresponds to the linear term, and then the square term. Okay, yeah. So this equation, step 2, find the roots. Okay, yeah. So let's write the quadratic equation in the standard form first. Then we write the two roots. Yeah, because we should have two roots, right? Yeah. Negative b, that's 4, plus minus root b squared, 4 squared, negative 4 squared, so still 4 squared, minus 4 times 1 times 2, right? Yeah. Over what? 2a, right? So 2. Yeah. So let's do simplification. 2 plus minus, so 4 cancellation, 4 minus 2, root 2. Yeah. So that's step 2. Yeah. Step 3, write a linear combination. Write the linear combination of the final solution. Okay, so a of n based on linear combination. Yeah, so if we, here, because we use the capital for the original function, so probably we use little a b. Okay, yeah, so little a first root, 2 plus root 2 to the n, b 2 minus of n, linear combination of two roots. Okay, yeah, for the general solution expression. Yeah, so that's step 3, the last step, step 4. Okay, all right. Yeah, let me copy the step 3 here. Yeah, step 3, we already have the general form, 2 plus root 2 to the nth plus b 2 minus root to the n. Yeah. All right. Then step 4, find a and b using initial condition. Yeah. Find the solution. Find the solution. Yeah. All right. So a of 0, plug in a plus b equal to 0. Okay, b equals negative a of 1, a 2 plus root 2 plus b 2 minus root 2. All right, yeah, equals 1. Yeah, but this, if we replace b by negative a, so a 2 plus root 2 minus 2 minus root 2 equals 1, right? Simplification of the number inside the brackets, 2 root 2, right? 2 root 2 times a equals 1. So a equals 1 over 2 root 2. Yeah. Then we can write the final solution as 1 over 2 root 2 plus final solution. Okay, so here you see the standard steps, 4 steps. So you get 4 points. Okay, all right. Let me finish part 3 right here.